Welcome back to the Voting DApp Code Explained, Part 2. As the smart contract is ready in Part 1, what we need to do now is to code the front end. Let's start with the JavaScript first, as it carries most of the processing logic of the Voting DApp front end. And we will go back to code the UI in HTML and CSS. We'll first define the names of the HTML document objects. Then we declare a variable for refresh timing control, and declare the variables we need for passing data to the charting library. Here, we declare a function to get the elements in the HTML document using query selector for coding convenience. We also need some variables to be used by Web3.js for the smart contract interface. The variable bytecode is declared to store the bytecode from the smart contract compiler output so that we can deploy the smart contract in the front end. The variable ABI is declared to store the interface, the application binary interface generated by the smart contract compiler for interacting with the smart contract. The first function in it is to check if the Web3 has been injected to the browser. If successful, it activates the built-in crypto wallet and interacts with the smart contract on the Ethereum blockchain. Because it usually takes some time to connect the smart contract on the blockchain, thus a short timeout like half a second is required when we initiate the interaction with the smart contract. For this demo DApp, we just hardcoded the candidate's information for this voting. An ID from 1 to 5 and a title from candidate 1 to candidate 5 is given to these candidates. This function, showCandidates, is to generate the HTML codes to display all candidate information. Then it puts this code segment to the HTML element items. The function is now executed here to display the candidate's information. Now, we need to write a function to close the voting smart contract. The variable data is used to specify using the current crypto wallet account and the amount of gas for this transaction when this blockchain transaction is launched. The contract instance.close will pass the data to the close function in the smart contract and set the button vote and close to disabled. The function joint voting will be used by the voters to connect the DApp to a specific voting smart contract. If the smart contract is connected, it will enable the button result and vote. If the smart contract is ended, it will display a message the voting is already ended to the DApp user. The function new voting is to allow the voting host to deploy a voting smart contract. The variable data sets the current crypto wallet account, the bytecode, and the amount of gas for this blockchain transaction. The storage of the blockchain is so expensive, so we want to minimize the data size on the blockchain by just keeping the candidate ID in this sample voting DApp. If other candidate information is needed on the blockchain, we may expand the constructor in the smart contract, and so we can push more data item to the blockchain. When it deploys a new smart contract, it will display an error message if it returns an error. If there is no error, we have to check the deployment transaction every 0.4 seconds because the blockchain transactions usually take time to complete. If the deployment is successful, we will stop the check transaction timer and push the returned contract address to the HTML element, then enable the vote button and the result button. The refresh data function will disable the close button if the current user is not the owner of the smart contract. Otherwise, it will enable the close button if the voting smart contract is not ended. The function will also check if the crypto wallet account has been changed. If it does, it will run the refresh data function again to reset the front end. The next function is get voting result. The purpose of this function is to retrieve the voting result from the blockchain to an array, so that the blockchain data can be used in the front end. The function getData inside the getVotingResult will call the getVotesFor function in the smart contract to retrieve the voting counts of each candidate. We now declare an array result_data for storing the data from the smart contract, and a Boolean variable is showResult to false. Then we write the function showResult to display the voting result. The result overlay will be shown or hidden depends on the Boolean variable is showResult. It calls the function getVoteResult and take the result array. Then the function calculatePercentage is called to calculate the percentage of votes received for each candidate. The function initBarChart is called to initialize the bar chart. And the function animateBarChart is called to display the bar chart animation in every 2/10 of a second. The vote function is to get the HTML element ID of the selected candidate in the HTML document and call the vote function in the smart contract to cast a vote to the selected candidate. Well, it now comes to the final sections to write up the functions to animate the display of the voting result. The calculatePercentage function is quite straightforward to determine the percentage based on the total votes against the votes received by a particular candidate. The initBarChart function is to generate the HTML codes for the bar chart. Finally, the animateBarChart function is to generate the CSS codes to animate the bar chart. The following code segment is to pass the data for the charting library and draw the bar chart. And the last code segment is to add or remove the class name for the HTML element selected LI and to remove the class active for the element checkbox. Well, the front-end processing logic are all done, and we will code the HTML document to host the candidate list and to format it with CSS in the next section.